Good morning, student. Let's start today's class. Okay. In today's class, we are going to discuss about, or we are going to study about cyclic redundance check. That means one another method of error detection. Okay. First one is simple parity, or even parity, or odd parity, which we will study in previous classes. Okay. In today's class, we are going to study cyclic redundancy check, or CRC. Okay, one of the most common and one of the most powerful error detection code is the CRC, which describe as follows. Okay, given a k bit block of bit blocks of bit or message, k number of bits are there in the block of message, okay, which we want to send. Okay, the transmitter generate an n minus k bit sequence, okay, known as frame check sequence, okay, such that the resulting frame consists of a n bit is exactly divisible by some predetermined number. Okay, the receiver then divides the incoming frame by that number, and if there is no remainder assigned, that was no error. Okay, here what happened in CRC, what happened in CRC, what happened, there is a given what uh, bit, which is k number of k bit. Okay, k number of bit, okay, let's say, and we add some zeros. Okay, that that is the n minus of zeros. Okay, n minus k of zeros, and then we divide the whole number by a predefined uh, binary bit, which is divisor. Okay, then, and that divisor number is this n minus k plus 1. Okay, the number of zeros we add plus 1. Okay, that that number of bit are there in the divisor. Okay, and that divisor and that binary bit we divide by divisor, and we get some remainder. Okay, and that remainder we add to the uh, our information and send to the receiver end. Here the receiver, what are doing the receiver also getting the uh, code. Okay, and divide that code by same binary divisor, and if the remainder or the result is 0, okay, then no error. If result is non-zero, then there is some error. Okay, we'll see in example, and you can understand better. Okay, now let us see what happened in our encoding. Okay, let us take a closer look at the encoding. The encode takes the data word. Okay, data word, what is data word? Data word is the block of data, or the information which we want to send. Okay, that is called data word, and uh, augmented it with n minus k number of zeros. Okay, the n minus k number of zeros is added to the data word. Okay, it then divides the augmented data word. Okay, augmented data word by the divisor as shown here. Here you see what happened. This is the word, data word. That means we want to send 1001. Okay, then we want to send 1001. Okay, then what are doing the encoder, what are doing that this 1001 plus add in the right side of the number of 3 zeros. Okay, here 3 zeros added in the right side of that uh, data word. Okay, and divide them by the divisor. Okay, by the divisor. This divisor, okay, why we add or how we add this divisor, okay, is really given to you in the question. Okay, that the divisor is fixed, okay, in the encoder and also in the in the sender and or in the receiver end. That divisor is fixed and this is given to you in the question. Okay, and this also given to you in the question. So from the divisor bit we know there are 4 bit, okay, divisor. So we should add one less bit than the divisor. That means we here is 4 bit, so we add 3 zeros to the our data word. Okay, this is the formula. Okay, the number of divisor, the number of bit in the divisor is one less or one greater than the number of zeros added. Okay, that means divisor is given. Okay, then from the divisor bit number we can find our zeros number. Okay, and add to the right side of the our data word. Okay, okay, and that is called augmented data word or dividend. Okay, then we divide that by this divisor, but here the divides is not similar or is not simple divide and binary division. It is modular to binary division. Okay, here modular to binary division happened. Okay, and what is modular to binary division? That means modular to binary division is same as general binary division, except in the place of general subtraction we use uh, we use we use XOR truth table. Okay, or XOR concept. XOR truth table, what is XOR truth table? When two bits are same, 1 1 or 0 0, then we get output 0. Okay, when two bits are dissimilar, then we get output 1. Okay, this is the XOR concept. And here we use XOR concept when we uh, when in the general what general division we minus this from this. Okay, and get that amount. In the subtraction, in this place of subtraction we use XOR. Okay, let's see how the XOR is used. Okay, here you see this is 1 0 0 1 0 0 0. 1 0 1 1 1 is divided. Then first of all this is 1, this 1 k 1 and 1 0 1 0. Okay, and in this place in general division the subtraction is happened, but here in modular 2 division the XOR concept is here. Okay, how the XOR concept is 1 1, that means the two bits are similar, so in due to XOR concept it is getting output 0. Okay, there is dissimilar bit, so output is 1. There is similar bit, output is 0, and the right hand side one bit is uh, drop down. Okay, then one concept is when the dividend, this is also dividend. Okay, this is dividend, this is also dividend. Okay, and when the leftmost side of the dividend is 0, okay, then we cannot divide by that divisor, okay. So we place all zeros, okay. So here we place all zeros, okay, 0, that this 0 and 0, okay. So here similar, so 0 similar bit 0, dissimilar bit 1, okay, and the next bit is drop down, okay, 0. Then here the leftmost bit is 1, so we can divide this 1 1 0 1 1 into 1 1 0 1 1, okay. Then we XOR dissimilar 1, dissimilar bits 1, similar bits 0, and the next 0 is drop, okay. Then here also the leftmost bit is 0, okay, so that we cannot divide divide this dividend by our divisor, so all are zeros, okay. Then remainder is 1 1 0, this is the remainder, okay. And now the code word is which we send in the transmitter, okay, after encoding, the which we get after encoding, okay. Then you see this is our actual information, okay. We add the remainder, okay, 1 1 0, okay. So the this is called code word or coded word, okay. This code word is actual word plus the remainder, okay. We send this to the receiver end. Now let us see what happened to the receiver or receiver end. If the receiver code word is 1001 110, that means similar to the which we send, this will we send, okay. This was sent by the sender, so this is similar, okay. So there is no error, but the detection concept, how the detection concept know that there is no error, let us see, okay. In the receiver end also, the received bits, received data is divided by that same divisor which will divide or which will used in the sender end, okay. So thus the divisor, same divisor is divides the received bit, okay, which is this much, okay. This one, this, okay. And in here also XOR concept, 1 1 similar, so 0 0 1 dissimilar, so 1 0 0 similar, so 0, and next bit is drop, okay. Here the leftmost bit is 0, so 0 all zeros, okay. Then 1 0 is dissimilar, so 1 0 0 similar, 0 1 0 dissimilar, so 1, and next bit dropped, okay. Here the leftmost bit is 1, so we can divide this 1 1 0 0 1, okay. Then 0 0 0, next bit is drop down, then 0, then all zeros, so 0 0, and we get 0 syndrome or remainder, okay. Since we get 0 syndrome, that means the we received data is have no error, okay. If we receive this 1 0 0 1 1 1 0 in the place of 1 0 0 1 1 1 0, that means this 1 is errorly converted into 0, okay. This is actually 1, okay, but in the receiver end it is received as a 0, okay. So there is an error, okay. Now let's see how we get that information. Divide by 1010, okay, 1k 1010, then we XOR that is 1 1, then the left hand side is dropped, and that is leftmost side is 0, so all zeros, and 1 1 1, and the next is dropped, then 1 0 1 0 and 1 0 0 0, that is 1 0 1 0, then remainder here you see the remainder is 0 1 1. Okay, so there is a non-zero remainder, okay, or which is called syndrome. Okay, so that we get to know that there is some error are there in our receiving data. Okay, you understood the concept behind the coder, encoder and decoder process. This whole process is called CRC. Okay, thank you.